Hey guys, this is John from Guitars. Today we're going to talk about doing accurate layout using a height gauge. Now, I'm going to happen to be doing it on one of these boxes for a prototype for one of my products, but it doesn't have to be on an effects pedal box. I use this all the time when I'm building guitars as well. Really slick for finding things like center lines or doing basic layout work. Basically, anytime you want to do some relatively high precision layout work, you can use this technique as long as you can find a nice straight edge to work off of. Other ways of doing it, of course, and what I'm going to show you, you can measure from an edge and you know, get a square and draw lines, and then measure up, get a square, draw another line, draw lines. There's a lot of ways to do it. This isn't the only way. You know, maybe it's not even the best way in all cases, but for a lot of cases, if you can get your hands on some sort of digital height gauge and some sort of flat surface to do it on. I happen to be using a granite plate. I'll talk about that in a minute. This is a really slick way to do it. So first, let me talk about some of the stuff I have here. This piece of granite. This is a granite granite surface plate. This is not a metrology grade granite plate. This is just an El Cheapo thing that I picked up at Woodcraft. I'm not sure how much it cost, but it wasn't very much. At least certainly not as much as a metrology grade one. It's good enough for doing this. It's good enough for putting down sandpaper and flattening things. For example, I make all of my nuts on here. I can get them really flat, get them very precise. Does a really nice job. Some people use these for sharpening. They put down abrasive film or sandpaper. They can use it to sharpen with. I mainly use it to do things like make nuts, or if I need a really flat edge, I can very quickly get a nice flat edge here, or for layout work. It works really really well. I have this digital height gauge. This particular one I picked up from, I had an older one that I finally broke. I picked this particular one up from a firm in Massachusetts called SR Measuring, I think. They also have another division or another website called SR Soldering. I don't generally get soldering stuff from there, but for some measuring stuff, they actually have some reasonably nice measuring stuff for not a whole lot of money. This particular gauge, this is a 12-inch gauge. I think I paid just about $100 for it. Depending on what you're doing, you can get a 6-inch gauge, which I think is less than $100, or you can get even cheaper ones. You don't need, for the work that we're doing, again, you don't need some sort of metrology grade measuring tool. You know, all you need is something that has a readout. Something that has some sort of readout. And I like to have a carbide scribe on it, and you're going to see why. They don't all have carbide, but the carbide's nice because it's very sharp and it stays sharp for a very long time. Okay. So the first thing I'm going to do, you don't have to do this, but it certainly helps. Here's my box. Let's back you out a bit. And normally I would do this a little bit neater. There's a stuff here called Dicum. You don't have to get this particular one. This is just the one that we all use. It's called layout fluid. What it is basically just lacquer. And it's just going to make it easier to see our lines. Now, this is actually going to scribe a little bit in here, or at least it can, if you wanted to. But with the fluid, we're going to get nice crisp lines. All you do, get the fluid and just paint it on. You know, you don't have to be Michelangelo to do this. You don't have to do the entire face. You only really have to do where you're marking. But when I do it, I usually just do the whole thing instead of trying to figure out, you know, where my holes are. I just do everything, and I'm done. This dries super fast. It's like nail polish. You could even blow on it, make it dry faster. Okay. So if you're looking for it, it's a few bucks from like a machinist supply. I happen to buy it from Granger just because I have a Granger not too far away from here. I think I pay like $7 for it or something like that, which means everywhere else on the planet it's like $2. But if I only need one thing, you know, I just get it from Granger, so I don't have to pay for shipping, and that works well. And right now, I want to mark the other side too, so I'm just gonna blow on this. Just to dry it real quick. This dries really fast. Typically, you're ready to go in just minutes. See, we're already dry. I'm going to put it down to the other side. Again, this doesn't need to be nice. It's just going to make it easier to see our marks. On wood, you wouldn't need to do this at all, of course, on wood or plastic, because you'd see the scribe marks. But on aluminum and steel, this definitely helps. And I'm actually going to do an extra side. I'm not going to have any holes on this side, at least not on this particular box. But I'm going to do it anyway because I want to show you guys something that I wouldn't be able to show you otherwise. Okay. So now we have the Dykem on there. Dykem, D-Y-K-E-M, okay? But if you go to any machinist supply and ask for layout fluid, they're going to have it. Like if you have a Fastenal nearby, sometimes they carry their own brand. They can get it in a day or two. But pretty much Dykem is what we've all used forever. Comes in red too. Okay, so we're all nice and dry. We're all nice and dry. We're ready to mark. Like I said, this dries super fast. It's nitro, if you can believe that. Just nitro lacquer with a little bit of dye in it. Okay. So now a height gauge. Funny because non-machinists think about height gauges and they go, oh, you know, well, okay, it lets me get a height. Well, what good is that? You know, how often do I just need to know a height? And you're going to see it's actually quite useful for a lot of things. So the first thing you need to do is you need to reference this from somewhere. So what I'm going to do, I'm going to take it down to the table, lay it pretty gently on the table, and I'm going to zero it. That's it. Now it's sitting at 0. I think you can see that. Okay. Let me show you how it works. There's a couple of doodads here. This is a fine adjustment. See, that's loose now. All these locking knobs are, let me lift this up a bit, all these locking knobs are loose. What you do is bring it to about where you want it, okay? Gently lock the fine adjustment, and then, let me lock it a little bit tighter, and then you can move this up and down. You can see I'm moving the whole thing up and down, so I can get very, very precise adjustment there, okay? And then when you get what you want, you just lock that one down. Now let's unlock them both. First thing I want to do, I'm not going to use the center line on this particular box, but I'm going to show you how to get one, because that's one of the really convenient things you can do with a height gauge. So how do we get a center line? Well, bring it up. See, so now I know that that's zeroed. See, that's 0. Okay. I'm going to bring it over to the box. Let's measure the top. You can see it measures 1.065, which means the center is 0.5325. Okay? So what I'm going to do, I'm going to set this. 0.53, lock it down. 0.53, and 0.532 is probably good enough. Okay? Now I'm set to 0.532. Now let's scribe our center line. This is brilliant. Ta-da. And that is a perfect center line right there. Okay? So that in and of itself is pretty cool. All right? Instead of having to go and measure and this and that, that's pretty cool. That's pretty cool. I didn't measure, I didn't scribe that very hard, but normally I would scribe that a little bit harder. But it gets better, and the reason it gets better is these particular boxes, because they're cast. This is actually a Hammond 1590B. This one's not bad. In fact, these are really good. A lot of cast aluminum boxes, especially the cheap ones, have a horrendous draft angle of about 3 degrees. Now this box has about 1.5. I think it's like 1.3. So it's not too bad. And in fact, you can maybe even barely see it, but the bottom of the box is bigger than the top of the box, because when you put it in the mold, right? If these sides were straight, you'd never get it out. You know, you'd break the mold before you ever got this out. So you need to have a little bit of an angle so that it actually will release when you try to get it out of the box. And like I said, this particular one is pretty good. All of the Hammond ones are really good. Some of them are really bad, but if I put this down on its side, you might be able to see it a little bit better. In fact, let's bring a straight edge over to it, and a square. When I do that, maybe now you can see. And in fact, that's not square. In fact, that has a bit of an angle to it. You see that? Well, maybe you can't. Let's try it like that. Put something white behind it. There. See? See, the top of the box is tight. This has a little bit of an angle. Okay? That's the draft angle. It actually makes it quite difficult if you want to do a precision layout to lay something out on the top of the box. Because you want to draw here, right? But you can't draw there when you're like this, right? And just measuring from here does you no good, because you wanna be on this surface here. So what you end up to, and plus the edges are round. It's just not easy to do this precisely if you're just doing it with calipers or rulers or anything else. It's just not. But doing it with a height gauge is very easy. So what I'm going to do, I have my plans, my little print here. It's all very accurate, all laid out really nicely. What I'm going to do is I'm going to lay out the front of the box first. Okay. So I can see from my plans here. First I need, well, I don't know if you can see, but I need a line going up the middle, 191 thou from an edge. And what we're going to do, we're going to pick an edge. We're going to pick two edges, and we're always going to lay out from those two edges. Okay, I'm going to pick these two edges, and that's all of our layout. From this edge, that edge, and from the bottom, okay? So there's a line going up the middle, 191 thou. That's going to have all sorts of holes on it. It's going to have the hole for the switch, and for an LED, and for a knob, and for another switch, and blah blah blah. So the first thing I'm going to do is set my height gauge. I'm going to go to my height gauge, set it for 191 thou. I'm sorry, 1.191. Now we bring this up. 1.191. Okay. And now the trick here is to get rid of that draft angle. You can put it up against a block or anything else, but this is why a height gauge is so useful. It's not just for heights. Let me see. I'm kind of in an awkward spot here. I'm just going to hold it up against a square, and I'm going to scribe. Okay. See, it is the height off the plate, but you can move this to scribe whatever whatever axis you want. You see? It's not just for heights. I mean, it is just for heights, but the work surface, the work piece moves. Okay. Now you can see that stomp box switch, stomp switch. It's going to be at 1.46. So I'm going to set my gauge 1.46. And normally when I do this, I just scream through it because I'm not talking and I'm not in an awkward angle. There we go. Same deal. Scribe it. Ta-da. Okay. LED is going to go at 2.625. 2.625. Lock it down. Let me do this so maybe you can see it a little bit better what I'm doing. Like I said, this is really awkward. See that? Okay. You guys get the point here. I need another line going all the way across. It's 3.055. This is going to be for a bunch of knobs. But now what I want to do, I want this to come down a bit. What I'm not going to do, this isn't going to be a drilling tutorial. Maybe I'll do that later. I don't know. This is just strictly layout. 3.055. Near enough. Look at that. Okay. Let's see. Need another line going across at 3.92 and 3.95. So let's do 3.9. Oops. And again, this goes much faster when you're doing it for real. Let's do 3.92. That's top knobs. And 3.95. Which I can probably just go up from here. For a little switch that goes in the middle there. Okay. Now we'll flesh it out. Going the other way, I need a line going the other way at 0.440. .43, 0.440. Remember, we're going to go off of this edge. Just go off the same edge every time, and you'll be fine. And I need another line. Oh, actually, that was up here. I need another line at 0.626. I'm just reading these off my plans, off my drawing here. 0.626. Near enough. I have one extra line on there that I did by accident. I need one at 1.755. 7.4755. Which one is that? That's the top one. And 1.940. There we go. Oops, let me try to make it so that you can maybe see it. And that's it. Obviously, the sides, I mean I could show you the sides of the box as well, but they're going to be exactly the same as the face of the box. Maybe I'll just do it just for the heck of it. But you can see when we're done what we end up with, and sort of ignore that line there. I meant him to be there. I mean, you can go all the way across with these lines, of course, but it's neater if you just put them at or about the whole location, and it makes it less likely that you're going to make a mistake. But you can see now I have an extremely accurately laid out box. I mean, this is probably laid out to 1/1000th of an inch. Even just being very sloppy the way I was, I probably easily, these centers are probably easily within, 1 or 2/1000ths of an inch where they need to be. And if you properly punch them, mark them, punch them, maybe start them with a spotting bit, and drill them, you can get drilled holes by hand that are within, a few thousandths of an inch without really trying all that hard. I'm not going to get into that in this particular video, but maybe I'll do it in a future one. But this was just strictly about layout and a height gauge and how you use such a thing and why you'd want to, and there you go. That's it. Questions, comments? Let me know. Thanks.